Everyone, thank you for coming out to our EOS DApp development meetup. I think we've had a lot of blockchain events this past week, so we have usual bigger groups, but I know everyone's been traveling. I know we ran into each other in San Francisco this weekend, and there's a lot of work happening, but we're so happy to have you here and so the rest of you guys here. And this is just kind of a series to encourage DApp developers and stuff that we're actually building and share tips and tricks and all that. So now we have Rami from Everpedia ready to go. So thanks everyone for coming. Take it away.
Yep. Thanks a lot, Alex. Thanks for the introduction. As I said, or as he said, I'm Rami from Everpedia. I'm the Director of Communications. My title of the presentation is Decentralizing Knowledge with Everpedia. And so before I get into the presentation, just a quick show of hands. How many of you have heard of Everpedia before? And how many of you have tried editing on Everpedia? Okay, so hopefully by the time this presentation is over, you'll be convinced that you will want to participate and participate in the editing or the voting. We have notability guidelines in terms of what goes on to our knowledge base. So we try to be as inclusive as possible. If you have any questions, I have a bunch of business cards as well. So yeah, let's get started. In terms of why I decided to name this presentation Decentralizing Knowledge with Everpedia, as I'm sure a lot of you have heard, Everpedia likes to, I guess, we're perceived as this the decentralized knowledge base on the blockchain, or Wikipedia 2.0. And while that is the case, we are looking to shift into something bigger than Wikipedia 2.0, which I will get to right here. So what is Everpedia? For everyone who raised their hand, you already know this, but Everpedia, as in everpedia.org, is the first completely decentralized knowledge base on the blockchain. And so in terms of us trying to figure out what we want to do with knowledge itself and stuff, we have a much bigger vision in terms of just the one-liner of Wikipedia 2.0. So we want to decentralize knowledge in other ways. So it's not Everpedia is not just Everpedia is the knowledge base, but we are looking to launch the IQ network. So the IQ network is what I would like to call a knowledge network. It is basically going to create opportunities for people to develop different use cases other than, creating a consensus mechanism for encyclopedic content. So by the end of the presentation, hopefully you'll be able to, learn more about what it is we're all about in terms of like our overall mission. So in terms of the origins of Everpedia and how we got started, we basically, we started off as a website that, was looking to solve a problem. And it was not necessarily as big of a problem as we're looking at now by incorporating blockchain technology, but we kind of figured that there was no real incentive for people to actually edit on Wikipedia because it wasn't modern. It had a lot of convoluted guidelines in terms of what pages were deemed notable by the community. It's a very deletionist culture in terms of what is allowed on their knowledge base. So what we decided to do to kind of lay the foundation when we founded the company in 2015 was basically import all of English Wikipedia's pages onto our website. And since then we've basically generated an additional 1 million or so pages. So we have close to about 6.5 to 7 million pages now. And as a way of kind of letting people know the difference between Wikipedia and Everpedia, we were taking into account some more structured data and stuff that wasn't necessarily like manually created, which is what we've seen on more traditional knowledge bases like Wikipedia and IMDb and such. Yeah, this is kind of a couple of the metrics that we've seen over the last couple of years in terms of developing a brand pre-blockchain. Like I said, we started in 2015. At one point, we were the top 5,000 sites in the US, which was a big accomplishment for us. We have in between ranging between 1 to 2 million unique monthly visitors, along with 60,000 recurring monthly users, which is pretty decent in terms of trying to think of integrating with the blockchain. So from a developer's point of view, we do have quite a few programming languages that we take into account. Python is in terms of in terms of presentation, we use the CSS style. We use jQuery for the I guess the behavioral the interactivity and the behavioral aspect. For storage, we use Amazon AWS and Microsoft Azure, and since we're in EOS DApp, we're operating on C++ as well. And yes, I'll be talking about the blockchain element specifically, but in a nutshell, in terms of what Everpedia, or what the blockchain did for Everpedia was completely decentralize the network, so it's not just based on centralized servers anymore. And it also gives people the opportunity to be rewarded for the contributions that they make. So just in terms of, looking at things from maybe a more dichotomous point of view, we saw what Wikipedia did to Encyclopedia Britannica, and we felt that there still is a lot more room for improvement in that sense, in terms of what Wikipedia has done. So we want to do to Wikipedia what Wikipedia did to Britannica and kind of create this, evolved knowledge base / knowledge network. And then obviously because we've been, a part of, because we've been, a website that's been gaining traction over the last couple of years, this is just, a random slide. I think this was taken at night, about 175 users in real time that visit everpedia.org, like at a given time. That's usually our base rate right there. And there's also a recent activity feed where people can actually, view the content, edit it if they want to, and can also vote. This is a more recent photo of the, I guess, the blockchain version of Everpedia. Let's see. I think it's stuck. Oh, there we go. So just a couple of key highlights. Like I said, it was founded in 2015 by our president, Sam Kazmian, Theodore Forselius, he's our CEO, Mahmoud Moghadam is our CCO, our Chief Community Officer, and Travis Moore is our CTO. And Sam and Travis are UCLA alums, which is why we founded the company in right next to UCLA's campus. About a year ago, in October of 2017, we hired the co-founder of Wikipedia, Larry Sanger, who saw the vision and basically understood that blockchain technology kind of integrates all of these these awesome qualities of a knowledge base and a knowledge network. In February of 2018, we received most of our funding, $30 million investment from Galaxy Digital. In July of 2018, we actually did an airdrop with the IQ token. So anyone who owned at least one EOS got a ratio of 5.1 IQ to 1 EOS. Assuming that they got their registered account. And in September of 2018, which is a couple months ago, we actually moved from a centralized database with, a bunch of editors that were editing on centralized servers and stuff, onto what is now the blockchain version of Everpedia. So getting more into why Everpedia moved to the blockchain, we saw an additional problem aside from the modernization aspect. So centralized applications like Wikipedia and Reddit and YouTube, the first thing that comes to mind is access to knowledge. So with centralized applications like Wikipedia, I don't know if you guys knew this, but there was a campaign to the Turkish government specifically, trying to get them to say, Wikipedia was basically banned in Turkey, and we wanted to uplift this ban. We saw the same thing with Reddit and with YouTube. To kind of give you a rundown of some of the countries that censored Wikipedia. China obviously is a big one, Iran as well, Saudi Arabia, even the UAE, which is more of a modern, modernized Middle Eastern country, which I spent 2 years in. They censored, I think, Wikipedia for a little bit, and YouTube as well. So yeah, in terms of these solutions and how decentralized applications can solve this problem, we want to create, obviously, a peer-to-peer network that where censorship can basically become impossible for government entities and institutions to basically block access for people. And so, just kind of reiterating what I'm saying, in terms of democratizing a self-governed knowledge network, we want to reward people for the contributions that they make with IQ tokens, and curating articles through voting. And so we have a 3-contract system, which is it includes the token module, which is used to actually stake the tokens and interact with the system in terms of voting. There's the article module in terms of the editing interface, where hashes basically get replaced based on whether the community wants to accept them or not. And then there's the governance mechanism, which basically implements site or network-wide rules. And so in terms of IPFS, we have all of our data from the articles that we create stored on IPFS, which stands for the Interplanetary Filing System. It kind of works like BitTorrent in a sense, where basically anyone with an IPFS node can generate or regenerate these hashes. And the IPFS filing system is basically what makes it virtually impossible for anyone to kind of block Everpedia's content. So the token information. So as a starting supply, we started off with 10 billion IQ. And in terms of how the system works, the newly minted tokens are generated, or they're minted every half hour. So all of the accepted hashes that are put onto IPFS are basically going to, people are going to get a proportion of the IQ rewards that are generated every 30 minutes. And this goes with, it's also important to note that it's not just the editors, but it's also the voters themselves as well. So if you participate in the voting process, you actually get newly minted tokens as well, a proportion of that. Right now, the IQ reward available is subject to change. It's going to range between 1% to 5%. Similar to kind of how EOS's inflation works in that sense. But again, the amount available per 30 minutes is going to be generated like this. So if I'm an editor, I create an Everpedia page, or I can edit the page. Once the server validates that you're proposing a transaction, once you're connected to that network, it goes up for voting, which is through a 6-hour time interval. And based on the accept or reject ratio, if there is if that accept reject ratio is above 50%, saying that if you have 50% accept votes or more, then you will then the people that voted within that majority get the curated the minted IQ tokens or as a reward, and the same goes for if you reject. So it's based on a majority rule. Staking tokens. So in terms of staking the tokens, it's important to note that we have a fungible and a non-fungible asset. So the sole purpose of the IQ token is solely for staking at this point. And when you stake IQ tokens at a 1-to-1 ratio, they get locked up for 21 days in exchange for brain power, which is what you need to contribute to the system. And where the voting comes into play is if your vote gets rejected, then along with that initial 21-day period, your tokens get slashed for an additional period of time. And the reason why we do that is to kind of prevent people from just migrating and just solely transferring IQ tokens back and forth.
Quick question.
Yep.
The CPU. So when you're using this Everpedia, is CPU a problem, or is it already sponsored by some other network, like CPU emergency or links?
I believe the CPU has been an issue in the past. People have had to stake CPU for, they've had to stake more CPU over a longer, or I guess more CPU because there are more transactions obviously happening within the EOS platform. I am not too sure about the CPU and the net process though. That's a good question that I'll probably bring up to tech as well. So yeah, this is in terms of staking IQ for brainpower. This is what it looks like in terms of the brainpower management. So if I had 10 IQ, I could just put a new stake, and then it would generate a smart contract that would insert brainpower into your account as well. So that's what it looks like. And then just as just really quickly, I guess, in terms of Scatter, Scatter is basically like an identity management tool. In terms of why you need it, it's more of it's basically a desktop app. It's also in the form of a Chrome extension, but for us, you specifically need the desktop app in order to make this work, or to make transactions on the IQ network work. So basically, you would put in your EOS private key, and that would be used to basically log into just about to any EOS DApp. So it would be Everpedia, it would be EOS Bet, or any EOS DApp that's or any DApp that's functioning on EOS. And then this is just a screenshot in terms of what the voting process looks like. So as you can see, there's to give just a rundown, this is the time remaining, so it's a 6-hour time interval, like I said. And then there's the accept and reject ratio as well. And then as you can see here, you can see the proposed changes. And then if you wanted to vote, for example, this is an example of just what it would look like if you wanted to put 10 accept votes into here to change this from 77 to 87. So, yeah.
Is the accept vote, is that considered part of brain power or part of the IQ token?
Yeah, sorry for not clarifying. So this is, you're submitting 10 brain power. So what I was saying before is that the IQ is solely for the staking process. So if you want to vote, if you want to propose an edit or anything of that nature, you basically have to, submit brain power itself. And if you run out of brain power, then you would either have to stake more IQ to get that brain power immediately, or you would have to wait for however long it takes for the initial staking period.
Okay.
Yeah.
And then so you vote with this 10 brain power, and then if you vote in the way that it gets accepted, you get more coins?
Exactly. So you get newly minted IQ tokens as a reward. So that's both for the voter and for the editor.
Okay.
Yeah. But you're submitting brain power. The brain power that's staked is that it's linked back to what you initially staked in terms of your IQ. So
Sure.
yeah. So if you were to make an edit or a proposed edit and it gets like, let's say it gets rejected or something like that, that's actually what I'm going to talk about right now. So in terms of the slashing, obviously, like I said, we want to kind of have a majority rule type of consensus mechanism at this point. This is going, it's for two main reasons. To prevent, for the lockup period, like I was saying before, in terms of the staking, it's going to prevent, repeated attacks on the network, and it's going to enhance participation for, it's going to generate discussions basically in terms of the edits that people make. And so in terms of the slashing process, with the IQ that's staked with the initial 21-day period, if your edit gets rejected or if you vote in the minority, then your brain power, or the IQ that's linked to the brain power, it gets locked up for an additional period of time. So let's say, back with that example, I edited, let's say that this got rejected 100 to 90. Actually, I think I have an example here. Yeah, so user has 200 brain power and votes no using their brain power for an edit proposal. The total votes equal 2,000 brain power with 1,500 BP votes. So this basically means that out of if you add the accept and reject votes, that would be the 2,000, and the 1,500 represent the accept votes, and the 500 votes, or the 500 represent the reject votes. For the people that out of this total, because you put 200 brain power in there, you're going to have to see an additional lockup of 10.5 days on top of the 21 days. So it's kind of, it's a little complicated in terms of the equations and stuff like that, but basically what this means is, because you were a part of the minority, just on a holistic level, your brain power is going to be subject to the additional, the additional 21 days in which you staked the IQ tokens. So in terms of what's next, I said.
Quick question.
Yeah, go ahead.
You can see perpetually whether or not you're voting into the minority or majority, right?
You can always see the voting page. Like I said, it is at a 6-hour time interval, and there's a specific link in which you can visit for that proposed hash. And so if you click on that link, you'll see the 6-hour countdown, and you'll basically see in real time whether you are in the minority or the majority. So.
Does that sway, how you're going to vote, and then separately, can that be gamed?
It could, in a way. In terms of gaming the system, there are kind of alternatives. So let's say you're not in the majority. You could always propose an additional edit to that if you wanted to. And you don't have to necessarily do that once the 6-hour time interval is over. So you can have an overlapping edit if you wanted to, just based on what you yourself want to do with the tokens.
Do you get, in terms of the reward for voting, do you get more reward if you vote on something, like in the beginning? No. So it's not dependent on whether you vote in the first hour versus the last hour or something like that.
Good question.
That is a good question.
You should be penalized the later you vote, right?
It should be like a prediction market.
Yeah.
It's an interesting thought.
It's just an incentive to vote on like anything that's is going to end soon, and who's winning. You're just going to vote with the same on the same side.
Exactly. That's what I was talking about with the swaying of the votes.
Yeah. I mean, it's
less if you can sway it.
It'd be an interesting thought, like to kind of maybe make a counterpoint, I guess. If I am in a different area or something, and I just wake up or something, and I see an edit, would I be penalized just because I'm in a different time zone or something like that, or just because I logged in at a different time than someone else did or something like that? So how would we go about that? But I mean, I like the thought. It's an interesting point for discussion.
If you don't mind, you could take the approach of, if you kind of missed it, then, and it's going to be worth less now because you're late to the game, then just don't participate.
That's something that we wouldn't want to disincentivize people from, like, the actual voting process, though. That's the thing. So
Would
yeah.
it possible to limit the ability to see like what other people are voting like towards the end?
I believe you can. It's just not on the editing interface at the moment. What currently is seen just on the front end is which EOS accounts voted for or against. But I think you would need to refer to the actual block explorer of like that specific EOS account right now. But that I think would be a good feature to have for sure. So yeah, just as I guess to wrap up, in terms of what's next, this is kind of like a timeline in terms of the of what we've seen in terms of the blockchain highlights. For next month, I'm going to talk about that right now. So I talked like in our intro about the use cases, specifically the multiple use cases of actually creating something within the IQ network. So initially what we wanted to do, and it's further explained in our white paper as well, is create multiple front ends so that the infrastructure so that multiple front ends could use the technology that we've built onto our knowledge base. So to give a couple of examples, IMDb or the Met, a museum or a library, even Wikipedia if they wanted to, they could take the technology, the open source code that we have, and put it onto their website in which they actually have user base for people to contribute to. So that's that would kind of build a sense of it would kind of solidify the token in and of itself, and it would help enhance the network in terms of trying to create this knowledge economy in terms of stimulating it and
So
stuff.
you're grabbing content
cool.
like already from Wikipedia, but like the other two, that's going to be starting to grab content from those two? Or what exactly is going on? Or those
So you're getting distribution out of them and they're getting content.
So they can basically take the infrastructure and or the data, as long as it's like if they take the data based on copyright laws, they have to basically cite Everpedia,
Yeah, like the comments.
the Creative Commons right, exactly, yeah. So
Like, what in regards to that?
with
Like Chinese content?
with Chinese content in regards to
I forgot what's the name of it.
like Baidu or.
Is that allowable? I think they have different comments. I'll check back with you.
Okay. Yeah. Sure. I think with the Chinese Wikipedia or the like a Chinese knowledge base, like we would obviously have to work individually with each knowledge base to make sure that we're doing things the legal way, right? But that's ideally like if someone wanted to like create a front end with and they had a user base specifically for, let's say, aerodynamics or something, or like zoology, like with endangered species or something like that. If they wanted to filter that content because they felt that they would be providing more of a better user experience for that site or for those people, then they could absolutely do that just by filtering the content itself onto and providing maybe like a rewards program for them that is completely decentralized as well. And then the second thing, and the last but not least, would be in terms of the multiple use cases. We're kind of thinking about how to not just create a decentralized knowledge base in the sense of an encyclopedia, but what if we were to take things in the form of Q&A, or in terms of oracles, where you basically automated the data and put it onto the blockchain. That could definitely be useful in terms of, in our opinion, in terms of creating this knowledge network for sure. And yeah.
Two examples, actual deals you have in place, or those are just hypotheticals?
Those are hypotheticals.
Okay.
Yeah, all these are hypotheticals at this
I
point.
knew Wikipedia wasn't, but the other two.
Yeah. But that's based on the like what we're building. That's ideally what we're looking to try and build at this point. Yeah. And then that's it. So like I said, I have a bunch of business cards. If you're interested in contributing, or if you're interested in learning more about the learning process, follow us on Telegram. We're very active on Telegram. You'll see me on our main Everpedia Telegram, as well as Twitter. And then if you want to contact with me personally, that's my information there as well.
Cool.
Yep. Thanks a lot, guys.
Thanks, Rami. Any additional questions for Rami while we still have him here? He's not running yet, so all right.
Not quite.
We can chat with him after. So our next presentation is going to be someone from our team here at Sense, and he's going to be doing a little bit more of a deep dive into the actual tech parts of EOS. One of the tools talking about demux-js. So we're going to get Ross up here and maybe.
Okay, so as Angel mentioned, I'm going to be talking about demux-js. I'll get into what that is. But first, my name's Ross. I work here at Sense. This is a slideshow, apparently. Let's just do this. Sorry, I did this presentation earlier this week in San Francisco, and there were some technical difficulties, which I'm hoping to avoid today. Just do it as full screen. Okay, yeah, so my name's Ross. I work here at Sense as an engineer, right now working on the client, our iOS app. And I'm giving a talk today on demux-js, which is a tool that is I've found to be pretty useful for EOS. We're currently using it as part of our stack right now. So I'm just gonna quickly explain what it is, give an overview of how it might be used within a decentralized application. And then hopefully if the stars are aligned, my demos will work. And so I'll show you a quick little demo of what you can do with it. And then I guess just take questions. So hopefully, I'm going to try and go quickly, so I think we might be short for time. But yeah, if you have any questions, just ask me at the end and I'll try and answer. So yeah, why demux? What's the purpose? What is this thing for? So basically there's a mismatch between the information, the data that you can store on the blockchain and what an application might need, either the front end or some other service in your application. So querying it can be, a little bit difficult. You might need to query multiple times to get the data that you want. If you, are running an EOS node yourself, then that's great. Maybe you will need to at scale have to query a lot and maybe run multiple nodes, and so this can get a little out of hand. And so basically what demux does is gives you a way to persist data off-chain, but like sort of base all of that data off of the current state of the chain, and that will provide you with a more sort of flexible way of persisting your data, in whatever way you might want. Another issue is that smart contracts don't currently emit events that you can listen to. I know that maybe Ethereum does this, EOS doesn't. And of course you could poll if you wanted to. Actually, in fact, demux does poll the blockchain, but there are issues with the chain. If there's a fork, for example, how are you going to roll that back? You can roll all of that yourself if you want to, figure out how to implement that. But demux does it for you, so you don't need to. So that's kind of the high level reason for having something like demux. Yeah.
Can I ask you, what do you mean by an event? I'm sorry.
So anything that happens on the chain, say you have an app that is, we're all familiar with the EOSIO.token contract or a token contract. So a transfer event, that would be an example of event. I sent you some tokens. So right now, I can't listen for an event. There's this concept of an event-driven sort of programming model. What's that?
Like a transaction, basically.
Yeah, but more sort of specifically, there's the concept of having a feed. And so anybody could potentially be listening to this feed and then be notified that an event has happened. That doesn't really exist in EOS right now, as far as I know. Some other environments and languages and blockchains do have this. We don't, so we need something like demux.
So how does this exist in Ethereum?
I'm not sure. I've heard events being referred to in Ethereum like you could listen to a contract for an event. I could be wrong. I'm not an Ethereum expert, but
in Ethereum, there's this concept of a callback to an event. So you can put a listener on a specific item, and then your app, whether your JavaScript or whatever, can listen for those specific events. So it kind of works like a pub subsystem built into the network.
But it's still your local node that then.
Local node, or you can subscribe to an event on a public chain that you're running. So it could be something you're running, or in Ethereum, I think you have Infura, which you can use them.
Or you could do that with EOS too.
Yeah, this is kind of it's, I'll get into it, but yeah, maybe I misspoke, maybe there aren't events on Ethereum in the traditional sense, but yeah, this is kind of giving you a way to pull the blockchain and sort of source events in a roundabout way, I guess. So basically it's a JavaScript library, as you might have gathered from the JS. And this is an officially supported, maintained library. It's made by Block One. It's relatively recent, so there's still some issues with it. But yeah, this is sort of a first-class citizen for now in the EOS ecosystem. And basically, yeah, it pulls the blockchain and gives you the ability to listen for events, whatever you want. And then it also gives you sort of hooks to execute actions or execute certain functions based off of those events, and do things like update some sort of persistence layer. And it's agnostic to that. You don't need to run a certain type of database. It can be anything. And then also execute other actions like sort of side effect producing things, make calls to external APIs, or even initiate a new call in action on a smart contract, something like that. So yeah. So the sort of, I guess, steps to doing this, and I'm not sure how deep I'm going to go into all of this, but they provide you with an abstract action handler class, which you then have to go and create a subclass of, and then there's a concept of action readers. So the reason you need to do this abstract action handler, or you need to inherit from this, and then also number 2, import an action reader, is this is also chain agnostic. So there is an action reader for EOS, which is what we care about, but there's also an action reader for Steemit, perhaps others, and I think you can go ahead and implement whatever you want. Maybe somebody will do an Ethereum one, then you could do cross-chain events or things like this. And then what you need to do is basically write handlers. So you can watch for an event, and then what do you want to do when that event occurs? And then you call you set it. You call watch on an instance of this base action watcher, which is provided by demux, and then it's going to go and watch and keep polling and then go off and do its thing. So I'm going to not go into this. This is basically the abstract action handler. The reason you need this is it manages the state. So normally, right now, this is just a JavaScript object, but I think probably in a more robust production application, you would not be using this. You would have a reference to a database or something. And so this is going to be your state that's going to be that you can update based off of things. And then you need to implement a sort of rollback method as well. So what happens if there's a fork in the chain and things need to get replayed? So how are you going to handle that? And so this class here deals with that. So this is how you want to do it for your particular implementation. So then the important part, which we're all interested in, are the event handlers. So we have 2 types of event handlers. They are updaters, and these are things that you're updating a database or some sort of data store. And then things that have side effects, they refer to them as effects. And sort of how this works is you're going to create an array of your updaters, tell it what action you're waiting for, which has to be a string. The usual format is not like this. It's account name, colon, and then the action that's getting called on it. So this is what you're going to listen for. So if it was a token transfer, for instance, it would be EOSIO : transfer, I think is what they call it. And then what function you want to call when that action comes along in a block, and then you'll do something with that data. And so in the updaters, you don't have access to state generally directly. So you're not supposed to be updating state there. It's more, in the effects. So here you do have access to state. I'm sorry, so this is the updater here. You do have access to state here because you're updating state. And in the second type, the effects type of handler, you do not have access to state, although there is this context argument. So you can these all get called on a block or on an action that gets matched. So you can pass the context through. So if you need to have some kind of, I guess, a notepad sort of variable to do certain things, it gets zeroed out at the end. But you can do that. And so here you're doing you'd call your an API or something. And then these are also versioned. So this is important. As your application evolves, you might have to update these things. And so if you do need to replay the chain across versions, this allows the demux to know which version of your event handler to play at which point, because in each sort of iteration, each execution of your listener, you're going to have the block number and also the version of the handler that was used. So that gives you a record that you can go back and replay things appropriately. So, and then bringing it all together, you're just going to pass your action handlers in, which we've imported, into the base action watcher. You can also tell it how frequently you want to poll, and then up here you're going to pass some options into the action reader. This is the sort of chain specific reader. You tell it which node you're going to point it at, so it could be a public node or one that you run probably, and then also which block you want to start from. What's that?
You're hard coding the node?
You could. I think probably most people are going to want to run a node internally, and so you would just point at that one.
Okay.
But this is just more of a Yeah, just an example. So yeah, and then yeah, like you can specify a block number with which you want to start. So like if you're deploying your application today, there's no reason to listen from the first block. You just need to point to like the relevant block, and then it'll start listening from that point. So like practical use cases would be yeah, persistence. Like maybe you have like a social media app that has posts and likes, and those actions are going to get called, and maybe you want to like persist those in like a relational database, and so that will give you a much better way of querying the state of your application, rather than like querying the blockchain multiple times and then getting the ID for the user and then finding their likes and then all of this. Like having the client not have to know about that and having that sort of on your server or something is probably a better decision. Of course, there are downsides. Like I'm sure people are probably like thinking like have some objections to this, but I'll get to those later. You can also publish things to a pub sub. This is like how we're using Demux right now. We have a wallet built into our chat application, and we would like to notify users when they get a new transaction. So we're listening for transactions, and then we're sending push notifications to the client with that. So yeah, these are like a couple sort of nice things that you can do. And then now the time for recipes. Here's a couple, I've made two examples. One example of an effect and one example of an updater. These did not work at the last talk I gave, so I'm hoping that the internet here is more agreeable. So yeah, let me just quickly go over the code. This is an effect. It's listening for a token transfer, and it's calling this method here. It's really simple. All it's doing is just publishing each transaction. So the payload from that's carried with this, like kind of the argument to this transfer, this call and this transfer method is just getting published to IPFS. And then I've got a little client app that's listening for it, and then just like publishing them listening for them, and then updating the front end in real time. So, okay, this is probably not going to work. So. Oh, I should probably start my back end. Okay, so it's going to take a second for it to like connect to IPFS. Any minute now? Okay, there you go. So yeah, as you can see, this is just like, this isn't actually real time. It's yeah, so occasionally there's I'm not sure. Yeah, so yeah, this is working. This is cool. This didn't work last time, so I'm happy. But yeah, it's very easy. Just a couple lines of code, and you've got like your transactions updating in real time. Very cool. The next example I have is a little bit more complicated, but still relatively simple. This is using the updater. So like. It's an example of how you can use the state and kind of like accumulate the result of actions over and over again. Of course, here it's just like a JavaScript object, but normally it'd be a database or something else. And so yeah, this is also a token transfer example, and what it's doing is just like continually counting the number of transactions that have come through, and then also calculating the average transaction size. So it's very simple, but I think like this is like kind of a boring, dumb example, but I think you can imagine how you might use this in like a real context of whatever app you're building. So let me just show you this. Of course, we're gonna need there we go. Okay, so this is, I think I set the block number back. It's like from a couple days ago, actually. But at that time, this was like more or less real time. Oh, another thing I forgot to show in the code is you can actually specify whether you want like permanent blocks or actions in permanent blocks to be matched, or just like the latest. So depending on what your use case is, like maybe you want the latest transactions coming through, maybe you want to wait until they're like permanent.
So where does this data come from now? So this is not real time.
This is real time. I mean, well, I'm sorry, this is not real time. This is, so if I look in the code here, I will have to check what I've actually, so this is from block, what is this, 2,600,000 or 660 or 26 million? Yeah, so this is from that block. This is just what I set it at, like, because this code is old, but, so it's starting from that block and...
So it's starting from that block and then it's reading all the blocks and updating this metric.
Yeah, I could set it, so if you set this to 0, let's try this, I don't...
So the delay, because it does, I don't know, 10 transactions a second or something, that's because it takes that long to process this data, or why is there a delay?
Which delay?
I mean, it updates it quite slowly.
Yeah, I mean, that's...
You'd be able to run through all of these blocks and like...
There could, yeah, there's probably some latency in the, I mean, it's querying like not a node that's on this machine, and then, yeah.
You see the...
Oh, also, yeah.
Watcher, you have
Oh,
a
you have
250, yeah.
Yeah, this
So it's
is,
telling you the rate of polling.
Okay.
yeah, you can also set that.
It is set polling twice per block, so it should catch every block at that time. So
Yeah, it's like
250
half a,
there is what's causing it.
yeah, what is it, one block every half a second, so this is, yeah, it's twice per block. And you'll see, well, occasionally it will like, say it's like forked and then it's resolved the fork, it'll go and like log that stuff. But yeah, you can, yeah, not exact, pseudo real time, I guess.
Rates fork, that's in like in EOS.
Like a micro fork, like if you're listening for the latest, like the blocks that are not permanent blocks.
Why do forks happen in EOS? Are they micro?
I think mainly what we're talking about here is there's a flag that you can set if you want to only what do you call these? If you want to pull for irreversible blocks only.
Yeah.
So once they've been confirmed, then that's what it pulls.
Yeah,
If you set it to reversible blocks, which is a default, it'll get everything real time or close to real time, but you run the risk of something getting reversed.
So, I mean, maybe it's off topic, but
no. Yeah.
why are there reversible blocks in EOS?
I mean, I think it's maybe somewhat similar to like in, so yeah, these aren't, I guess they're not
Because isn't
blocks.
there one block producer per height? Why would that be reversible?
Yeah, so there's 21 like block producers that are like in a sort of round robin type of fashion going around, and each produces, I've forgotten how many blocks they produce, but I guess maybe if they switch, that's a good question. I'm not 100% certain. Maybe if it like I produce like however many blocks I get to produce, and then I go to the next, and this person, there's maybe at this transition period there could be like some sort of a discrepancy, perhaps. I'm not sure. That's a good question, though. Yeah, but it's supposed to have, when you write this abstract action handler subclass, you're supposed to like specify how you want to handle all of this stuff, and then deal with it. So yeah, and right now I think I'm not seeing any little micro forks happening because this is like quite old. I've started over like this is I think maybe Friday or somewhere around then. So yeah, but yeah, those are the two sort of very simple examples. And then I said I'd get the downsides. So yeah, obviously this adds like a lot of complexity or additional complexity. It's nice to think that like we don't have to run, or maybe sometime in the future we won't need to run servers because it's all going to run on a blockchain or on some block producer is going to run it for us. But this is an additional dependency. It's clearly also no longer trustless in the strict like sense of the word. I mean, it should be derived from what is going on the chain, but it's there's no like guarantee that I'm not manipulating things. So there's that, and it's also only available in JavaScript. So depending on how you feel about JavaScript, it's maybe a good thing or a bad thing. But yeah. So yeah, that's the end of the presentation. You had a couple questions. I don't know if anyone else has anything they're curious about, but I'd be happy to answer them.
How does that relate to Node.js, or is that a completely different thing?
Oh, so this is like written in Node.js. Well, it's the same essentially. Yeah, it's written in JavaScript, Node.js. The library itself is actually written in TypeScript, I believe, but it's at the end of the day, it's.
Can you find more info about demux-js?
Unfortunately, there's not a lot of information available right now. It's relatively new, but if you go to their library or to the GitHub account for the EOS main GitHub account and go to the library, they have some pretty decent documentation and a few examples in there, I think, that you can take a look at. So yeah, that's, I think, mainly where you would find out about it. Yeah.
When was this released?
I don't. Do you know? It's maybe a few.
I don't know if it became an official EOS IO library not too long ago, maybe a month or two ago, but I spotted it maybe about 3 months ago.
Yeah, I mean everything. It's all relative. Every EOS has only been I think live for 6 months or something like that. So, and were we talking about this? I heard that it was like an internal tool that they had been using for some purpose or another for a long time, like while they were building out the network at Block One, and they decided that it might be useful for people, so they released it. So yeah, but it still has a lot of issues. I recently found a bug, and they've been pretty responsive. They helped me try to debug things, and then they issued a fix within a week. So it seems like they're trying to maintain it, and yeah.
Any other questions? All right. Thank you. All right, so I'm going to talk a little bit about token migration strategies. ERC20 to EOS, that's something that we're personally going through. There might be some other companies that are going through it. I'm not really going to talk about it from the business perspective. There's other more qualified people to talk about it than me. But I will talk about it from the tech perspective and what it implies. So we have two chains. We have, not the wrapper, two chains, Ethereum, EOS. And now we have to figure out how do we get tokens from one of them to the other. What do we do with the tokens on this chain? Do we keep them there? Do we freeze them? Do we port them over? Well, how do we port them over? And for a lot of these things, we need tooling. We need to be able to have things make sense on two different networks. So there's different strategies how to do that. One strategy that we're using and we partnered up with is something that, a sister company I would call Shios.org or Shios.org, and the EOS 21 protocol. So basically what the EOS 21 protocol does, it takes advantage of some of the things on Ethereum, and then it takes advantage of some of the things on EOS. We were talking just right now with Ross's talk about the fact that Ethereum does emit events. Okay, so I can put a subscriber on a contract and say, when this action happens in this contract, let me know. And by let me know, it just means tell my contract, my code to do something funny with it, right? So we can go, okay, we set up a contract, and we call this here the black hole contract. And when this contract gets called, we go ahead and say emit an event. So let's see here. There's a method here which means teleport, right? So call this function teleport, and when this teleport function calls, let the code that I'm running on my server know. Now we have, in blockchain, there's this popular word called oracles. Oracles, in a simple sense, means stuff you couldn't run on the chain, so you're running it on your own servers and you're having it do something for you. All right, an oracle pretty much is just a little server that you're running outside of the blockchain that reacts to the blockchain, and it does something.
It's just feeding into the smart contract?
It could be feeding, it could be listening. It's just going to be outside of the blockchain world reaction, pretty much. So that's how, when you think oracle, it sounds very wise. It really isn't. It's just do something outside of the blockchain. Why? Because the blockchain is limited. It lives in its own kind of bubble, right? So do something outside in the real world so we can get some work done. So how do we do that? So on that sense, you have three pieces to this teleportation thing. You have an Ethereum contract, because if you own Ethereum ERC20s, you can sign for this. You can say, I own these with your private key. You can go here, I own these. Great, we listen for that. Now this oracle sits in between Ethereum, Oracle, EOS. So when something happens here, it goes, great, I listen to it. Is it valid? Can we double check the signature? Yes, great. Now this one will trigger something on this network. And that triggers some other function on EOS saying, okay, great. What are we doing now? Are we creating an account? Are we issuing tokens? Are we just validating public keys? And in its simple sense, that's all that's happening. Something happened on Ethereum. We can confirm that it's a valid transaction, make something happen on XYZ network. In this case, it's going to be EOS. Now, that's not the only strategy. That's the strategy that's probably the simplest. One of the things that we worked on with this contract was the fact that at first we were only going to take I think it was only going to be public keys. So then if you only take an EOS version of a public key, you can have that listen. And then with that public key, you go ahead and create now an account on the EOS network. But what if I already have an EOS account and I don't want 10 of them? I just want mine because I know how to manage one and it's already hard enough to keep your key safe. So now, another function was added where you can take a name instead, an EOS account name. Now the Oracle will validate. Again, that's the type of pieces that you want to make sure your Oracle does some things, because if not, you're going to be calling this other blockchain with bad data. And you really, as Ross mentioned, the minute you throw something outside of the blockchain into your stack or into your technology pieces, now you're adding a trust factor in there. It's no longer trustless. And everyone's honest and no one's trying to rip you off. But just the fact that you added another piece removes that completely 100% trustless piece of it. So you really want to make sure that your Oracle doesn't stop. You want to make it as basic, as simple as possible with the necessary validations to make sure that it just goes, doop, bounces off, and do the next thing in a very simple fashion. Okay, so that's one of the teleportation things. Now, what other strategies can you use to take advantage of the fact that we are working with cryptography? At the root of everything blockchain is the fact that you're just working with cryptography. In blockchain stuff, you're going to run into this term a lot, ECC, and in particular, 256, elliptic curve cryptography. Specifically the 256 version variant. I'm not an expert cryptographist. That's not my domain at all. But what I do know is that both Ethereum uses it, EOS uses it, Bitcoin uses it, and many other blockchains use it. So I was trying to figure out how to do things cross-chain. And one of the things that made it very easy for me to understand was when I figured out through readings and blog posts and different YouTube videos that I've watched, is the fact that really when you have a private key, regardless of which network you have it, all you're really representing is a large number. Okay, that's all you're really representing. And you're formatting it in a very different way. And I'm talking large numbers. And that's why in JavaScript, you have to use this thing called buffer. So you take a large number and you put it into something JavaScript can understand. And then people hash it. They turn it into their own format and they turn it into the 0x format that we're familiar with Ethereum. Or they turn it into your EOS. I think, public keys or public addresses. No, public keys and EOS start with EOS and then 5 something. And then the private keys are just formatted the same as Bitcoin and wallet import format. It's a standard format. You're taking this huge number, probably that, it'd be hard to understand, and saying, okay, let's pretty it up a little. Let's make it easy to understand, shorten it, and you do base 58 and then a couple other things, and you end up with this nice wallet import format. And that's the same format that Bitcoin uses. Knowing that is actually very valuable because it opens up the doors for your migration strategies. So did you see that Block 1 said if you forgot to register your Ethereum tokens, what do you do now? You miss the cutoff period and your tokens are gone. Well, they're not really gone. They can say, okay, look, how about we issue these tokens, we keep them in an escrow account somewhere, and how do we know that that is them who owns this token? How do we know it's really theirs? Well, they're taking advantage of the fact that the cryptography is the same under the hood. So they go ahead and take your Ethereum key and convert it to an EOS key. And that way you can take your Ethereum key, convert it to the same EOS key, and now you can claim it. Now you can claim it on a different network. The problem is that, and this is a bigger problem, we need to have simpler tools in blockchain so people don't get intimidated by it. And that's one of the things that I keep proposing, whenever I give a talk, whenever I give a presentation. Make very basic, simple tools that don't scare people. I was looking at one of the things, and it's actually very easy. It's through Scatter. And let's see if I find it here. I might have changed it. Sorry about that. But the point is that you can do this in a very nice and friendly fashion, but you need to download Scatter, you need to know how to use it, you need to do a lot of things. Then I found other tools that are like JavaScript libraries like this one. Nothing against the code is perfect, but you know, it says fill this in. Now, I'm not going to ask about this part. Maybe you're very familiar with GitHub and how to edit files, and you have your Atom or your Sublime or your Vim set up. So let's talk about your family. How many of your family members, cousins, aunties would know how to actually do this? GitHub what? Editor what? Right? It's too complicated. And get them to download something Scatter. So a lot of the development that I try to do is how do we get something just a simple tool? So for this talk right here, I didn't invent anything new. The code is pretty much compiled from different things out there. But how about we get a simple tool? So let's do an experiment, all right? Here's the code right here. And I made just a quick little program called key switch. And guess what it does? It switches your keys, right? So let's take, that's probably too small, right? Yeah, okay. That better? Okay. So let's grab an Ethereum private key here. Go ahead and copy it. I promise I have like 1 million ETH in here, so. Okay, but before we do that, let's go ahead and enter private key. Again, we have to have things that keep it simple for people so they don't make mistakes. So let's pretend we entered pizza because we thought that was our private key. Well, that's not a private key, right? So we have a little bit of validation in there. Let's say we got confused and we entered, let's see where to go. We entered our public address in here instead. We think that's the key. Again, that's not the right key, right? So let's go ahead and now do the right thing. We're going to grab our Ethereum private key. Again, this is an Ethereum private key. We're going to enter it there. And there you go. So we convert our Ethereum private key. We have a little validation just in case, you know, the code messed up somewhere. Double check that that is indeed your Ethereum public address. Okay, so we spit out the public address. And then we spit out a private key that you can use on EOS right now and a public key that you can use on EOS right now. Now, go ahead, Eli.
Who made the EOS accounts?
These are not accounts. It's just a public key. So EOS has this thing that you don't just use it like Ethereum where you just have a key and you use it. On EOS, you would need to make an account for this. So we would take this public key and make an account out of it.
So that EOS private key, is that not valid until an account is
Correct.
imported? Okay.
Correct. So how is this helpful? Maybe that's a perfect question to piggyback off of that. Let's say I can write a contract where we can take our Ethereum address, sign a message, and because it's the same cryptography, we can validate it on the EOS side, on the EOS side. And now we can automatically create an account for the user. And on EOS, we need a public key to create an account. We assign it immediately to this EOS 8E, whatever account. And we don't have to worry about ever needing to deliver a new private key to this user. We can just point them to some tool like this or some tool like Scatter and go, just generate that one. And you have access to it. You can sign for it. It's yours. See? So one of these things that I like about kind of going through experiments like this is the fact that it kind of demystifies this whole crypto thing. It's not just for super smart people. Believe me, I don't qualify in that arena. I'm relatively new to all of this. But if we can make very simple tools that make it very easy for people, then we finally get to this thing that we really want in blockchain, which is adoption. And part of that might be you started on Ethereum and it wasn't the right network to support what you wanted to build. So why make it super tough to switch to something else? So wanted to keep this brief. The code for this, again, not overly complicated, using tools that are already out there, just kind of packaged a little bit different. All right, so that's it. Any questions?
So you would say right after they plug that into Scatter?
Yeah, they can plug that private key into Scatter. It would pull it up. Yeah. Eli?
So was this account made when the snapshot happened? And like, so if you didn't register tokens, but you were holding, did EOS automatically like know, oh, they're holding?
So yeah, when the snapshot happened, if you never register an account, they have these kind of accounts assigned to these private public keys generated from that. So how do you access it? By converting your private key to a EOS private key. Yeah.
But isn't there like a practice to change like the owner key right away, or that's not part of this?
You could, but it's not really part of this. This is just taking, so on EOS, you create accounts, and each account has an owner and active key. And that's to kind of give you a little bit of an extra safeguard. In case you lose your active key, you can use your owner key to change access to it. What this is doing is just generating a EOS version out of the same Ethereum key that you already have, in case you need to do something cross-chain. One of those perfect examples for cross-chain was actually the snapshot. If you didn't register in time, then where do you send those tokens? Like, where do they go? This is the way. That's pretty much what Block One put in place. Let's take that Ethereum, understanding it's the same cryptography, and let's create an account with those public keys. And when you want to access it, convert your private key over to your EOS private key, and there you go. It's yours. Nothing else to it. You don't need to email support. You don't need to do any of that. It's all part of the cryptography and on-chain stuff. Zach?
I just want to say I appreciate that feedback. I feel like that's something that just doesn't happen a lot, where like you'll do something wrong and you just don't know what it was that you did, or even that you did something wrong. There's just no ending to it. So I think that just that design that you're feeding back to the person that there was an action and it maybe wasn't the right one, I think is a little underestimated for sometimes for how useful that is to the grandmas or the Zachs. Or that's a very useful thing, and it is done enough for that just ease of use. So.
Thanks, man. I appreciate that. You know, I'm on the engineering side, but lately I've been a huge advocate of UX. We need more UX on the blockchain space. So yeah, anything that contributes to that would help adoption. All right, anything else? Ross?
So I'm one of those people that bought some EOS in the crowd sale and then was late to register my account. If isn't there an extra step you need to take though? Don't you have to like petition? Like if at this late, I think 6 months later, has the account been created and all I need to do is prove ownership of that public key, or do I need to like actually petition like a block producer to create an account on my behalf, or?
I registered on time, so I don't know. But
I guess the answer is
no, I'm not sure. I'm not sure. They might have created it already, or maybe you petition. I'm not sure. But this, as far as signing for it, this would be the way you do it.
Yeah. Okay.
Yeah.
Cool.
Any other questions?
Yeah, they had a fallback method, and then EOS Authority passed a proposal for anybody that missed the registration date, they could still do it. So it's
So I can
allowed now.
still
Yeah,
go
you
and-
just go through it.
Yeah,
Read
okay.
the proposal from EOS Authority,
Okay.
and it shows like how you do it. Yeah.
There you go. Cool. Anything else? All right. Well, thank you everyone for coming out here. We really appreciate it. We want to keep these going, so if you want to present on something, even if it's a tiny project, you're just learning, those are perfect type of presentations for this, because there's always someone just learning here, and it might just be something we haven't touched on yet. So by all means, approach me. Rebecca helps me co-organize this, and then the whole Sense team right here. So thanks everyone for coming out. See you next one.